Hello student, today we start our next lecture on FEA. Okay, it's a 1D element. In this lecture we solve one problem on 1D element. Okay, one problem of 1D element. Okay, problem is analyze the bar for axial displacement. Assume E is equal to 2 into 10 raised to 5 MPa. Okay, and one diagram is given. This is a fixed size of bar. Okay, the area is 20 mm square and this area is A1 50 mm square. This is a A2. Total length of the bar is 30 mm. Okay, and force F is equal to 50 Newton. Okay, this is one problem. Okay, for solution of this problem you have to go for firstly converted this physical model into FEA model. First thing is convert this physical model into FEA model. Okay, and then they says that take a three element. Okay, then converted on the basis of this. Take a three element with assume E is equal to 2 into 10 raised to 5 MPa. First area A1 is 50, A2 is 20 mm square, then force is 50 Newton and length is 30 mm. Then for solution, firstly you find out the D1 and D2. Okay, find out the D1 and find out the D2. Okay, for D1 and D2 you know that area is equal to pi by 4 D square. Okay, same formula we use for finding the D1 and finding the D2. Then 50 is equal to pi by 4. D1 is D1 square. Okay, hence D1 is equal to 7.978 mm for solving this. Similarly for D2, this is for D2 is 20 is equal to pi by 4 D2 square. Then D2 is equal to 5.046 mm. This is the value of D2. We have to find out D1 and D2. Okay, first you go for this D1 and D2. Okay, then for next divided this 30 mm into 3 part, means one length is, if you divided this 30 mm into 3 part, then one length is 10 mm, 10 mm, 10 mm. Then this diagram may be considered as first, second and third. Okay, its a force is 50 Newton. This diameter you know that this is a third diameter. Okay, this is a DM3, this is a DM2 and this is a DM1. DM1 to 3 divided into 3 parts, 10, 10 and 10, 10 mm, 10 mm, 10 mm. Total it's a 30 mm size. Okay, this is a fixed side of the body. Okay, and on dotted you show that this is the original of the body. Okay, original size of the body. But you know that the dm3 is same as the d2. dm3 is equal to d2 is equal to 5.046. It's a given value. You can find out at here. Okay, then go for the next. From this figure we have to mean diameter, difference between minimum diameter and maximum diameter. d1 minus d2 is equal to 7.978 minus 5.046 is equal to 2.812. Just like that. If you divided, if you have to draw one line is here, one line is here, then this is 5.0416. then remaining value in upper side or remaining value in lower side is same. It is a 1.466 mm. Okay, and next one is, this is a 10 and middle of this length 10, then it's a 10 plus 10 plus 5, 25 mm. Okay, this value and this value you take for finding the value of y for this one, y2 for this. Okay, for y1 it's 1.466 divided by total length is 30, then y1 divided by 25. For 25 mm we have to find out the this. For 30 mm it's a 1.466, and for 25 mm for the middle diameter of that part, for finding the diameter of dm1, for finding dm1 we can find out the dm1. We have here dm3 is, you know, dm2 and dm1 you have to find out. Okay, then what is the value of, from this, y1 is equal to 1.22. Okay, then dm1 is equal to 5.046, it's a middle diameter, plus 2 into y1, its value getting 7.49 mm. Okay, next a1, area for that, pi by 4 dm1 square is equal to 44.061 mm square. This is the area for first, means the area for this one, first, second and third. This is the first, second and third. Okay, area for first, area for second, and area, we want to find out that area also. Okay, then a1 is this value. Okay, similarly for finding the dm, next step is, what is value of dm2? It's 1.466 divided by 30 is equal to y2 divided by 15. Okay, then y2 is equal to 0.733. Then dm2 is equal to 5.046 plus 2 y2, it's equal to 6.512 mm. Similarly a2 is equal to pi by 4 dm2 square is equal to 33.305 mm square. This is the value of a2. For value of A2. You already similarly the mid value for finding the DM3, you have to use the same 1.466 divided by 30 is equal to y3 divided by 5. Okay, y3 is equal to 0.244, then DM3 is equal to 0.456 plus 2y3 is equal to 5.534. Similarly, find out the A3 value is equal to pi by 4 DM3 square is equal to 24.053 mm square. The value of A3, value of A1, A2, A3. You have value of A1 also, A2 also, A3 also. Okay, got it. Then you have to convert this model into the FEA model. For FEA, consider here it's a fix. This is the total length. Here F is equal to 50 Newton. Okay, you know that. Here, if you consider 3 element 1, 2, 3, this is the end of that, then it's a force. Then first node, second node, third node, fourth node. Okay, if it is a 3 element, then node is the fourth. Here D1 F1, here it's a first element, second element, third element. Here D2 F2, here D3 F3, here D4 F4. Deformation and forces are there. Okay, first element, second element, third element. It's a 3 element and 4 node body converted into FEA. Okay, then next, for next we have to converted A1, A2, A3, D1, D2, D3, DM1, DM2, DM3, okay, into mathematical modeling. Okay, first draw a table. Element, node number. Okay, element, node number. Okay, for first element node is 1 and 2. For second element node is 2 and 3. For third element node is 3 and 4. Okay, for first element consists of 1 and 2, first and second node. For second element, second and third node. For third element, third and fourth node. Okay, then for element 1, K1 is equal to A1 E1 divided by L1 is a stiffness matrix. 1 minus 1 minus 1 1. It's a formula of stiffness matrix. Okay, for putting the value of all these three, we get 44.061 into 10 raised 2 into 10 raised to 5 divided by L1 is 10 into the bracket 1 minus minus 1 1. Okay, we will be get 10 raised to 4 outside of the bracket 88.122 minus 88.122 minus 88.122 88.122. Okay, this is the value of K1. Similarly, element 2 K2 is equal to 10 raised to 4. You can solve this. 66.1 minus 66.1 minus 66.1 and 66.1. Similarly, for element 3, K3 is equal to 10 raised to 4 into the bracket 48.106 minus 48.106 minus 48.106, 48.106. It's for 1, 2, it's a 2, 3, it's a 3, 4. Okay, 1, 2, 2, 3, 3, 4. 1, 2, then here 2, 3, here 3, 4. Okay. Go for the 1, 2, then for the global matrix, K is equal to 10 raised to 4 into the bracket, first row, first 1, 88.121, second minus 88.122, third 0, fourth 0. Okay, here minus 88.122, here 88.122 plus 66.1 first, here minus 66.61, here 61 is here, then 0 for third, here 0, here minus 66.61, then here addition of both 66.61 plus 48.106 minus 48.106, then next 0, 0, 48.106, and here is a minus, and here 48.106. This is the 4 by 4 global stiffness matrix. If you solve this matrix, then you will be get 10 raised to 4 into the bracket 88.122 minus 88.122, 0, 0. Okay. Next, minus 88.122, 154.2, minus 66.1, 0, 0, minus 66.1, then 114.206, then 48.106 minus, then 0, 0, minus 48.106 plus 48.106. This is the global stiffness matrix. If you write the relationship between global stiffness matrix K, deformation D, and force is KD is equal to F. Okay, and boundary condition is that deformation D1 is equal to 0. Boundary condition for solving this, D1 is equal to 0. Similarly, F1, F2 and F3 are 0. F4 is equal to 50 Newton. Where it is a mention? This one. For this, D1 F1, D2 F2, D3 F3, D4 F4. F4 is equal to, similarly it's a 50 Newton. D1 is a 0 because it's a fixed value, therefore D1 is equal to 0. Okay, you can find out D2, D3, D3, D4. Okay, you have to find out D2, D3, D4. This value we want to find out. Okay, then go for next. For putting this value in this equation, this is the equation number 1, you say that. Then it's a 10 raised to 4 into matrix X form is 88.122 minus 88.122 0 0. Okay, minus 88.122 154.2 minus 66.1 0 0 minus 66.1 114.206 minus 48.106 0 0 minus 48.106 48.106. This is the stiffness matrix into the D1, D2, D3, D4 is equal to forces 0 0 0 50. Okay, by eliminating the first row and first column, elimination method for approximate global equation solution, you have to eliminate first row and first column. Then you will be get 10 raised to 4 154.2 minus 66.1 0 minus 66.1 114.206 minus 48.106 0 minus 48.106 48.106 into the D2, D3, D4. You have to find out only these three values, and forces is 0 0 50. If you solve these matrices, you will be get D2, D3 and D4. By solving this, you will be get D2 is equal to 5.9023 into 10 raised to minus 5 in mm. D3 is equal to 1.3617 into 10 raised to minus 4 mm, and D4 is equal to 2.401 into 10 raised to minus 4 mm. This is the final solution of your problem, finding the displacement value for the three elements D2, D3 and D4. These are the displacement value for the elements first, second, third. Okay, got it? Okay.